The Earth during the Ediacaran was in some ways very similar to the way it is today, and in other ways it was very different. For instance, there was really no life on land. So, no plants, no animals, no forests, no grass, which means that the surface of the Earth was probably pretty ugly looking. There were still mountains, and there were still rivers and lakes, but nothing populating them. The oceans were also different because there was nothing big swimming in them. No dolphins, no fish, nothing like that. But the oceans were the same in that they still had waves and still had tides, as we do today, and they were still full of single-celled organisms, bacteria and single-celled algae, just like they are today. The atmosphere during the Ediacaran time period was very different than the atmosphere that we have today. In today's atmosphere, about 20% of the air that we breathe consists of oxygen, which is great because it means you can breathe. But in the Ediacaran, we think there was a lot less oxygen in the atmosphere. And we think that this reduction in oxygen level in the atmosphere played a role in the fact that most organisms that lived during the Ediacaran were pretty small. And so one reason why people think the Ediacaran fauna that you've been studying were able to evolve when they did was that at the end of the Ediacaran, when the Ediacaran fauna show up, oxygen levels start increasing. And more oxygen meant that organisms could get bigger and still survive. The temperature of the Ediacaran is probably pretty similar to what it is today, maybe a little bit warmer due to different amounts of carbon dioxide in the atmosphere, which acts as a greenhouse gas. But it's actually pretty hard to determine temperatures so far into the past. One of the things that would have been different in the Ediacaran is that the continents would have been in totally different positions. And we know this because we know about plate tectonics. So plate tectonics is the idea that the surface of the Earth is made up of plates that fit together like a puzzle piece, and those plates move around relative to each other. And that's one of the reasons why we have earthquakes. And those plates move slowly, so slowly that in your lifetime you'll never be able to see the difference. But over hundreds and hundreds of millions of years, the continents move back and forth all of the time. And so one of the other areas of research that geologists work on is trying to reconstruct the position of continents during the Ediacaran. We have some ideas, but there's still a lot of unknowns. Geologists try to determine the position of continents using a number of different techniques. One of them is called Paleomagnetism. And this is when they take a rock and they try to determine where the magnetic pole was when that rock formed. So some rocks, like volcanic rocks, when they cool from molten rock, they actually, little metal crystals inside the rock align to the Earth's magnetic pole. And at the equator, those little crystals are going to lie parallel to the surface of the planet. But as you move farther north, you'll start getting an angle in those little crystals. And that can help geologists determine paleolatitude. So, was the continent that the rock was on at the equator? Was it at 45 degrees north? Was it at 60 degrees north? Was it at 30 degrees south? And so geologists can use things like paleomagnetism to try to reconstruct where continents were.